The early versions of the chimpanzee genome were assembled based on the human genome. Basically, they hung all these chimp DNA sequences onto the human genome to put it together.
Welcome to the Creation Today show, where we bring together interviews with experts and solid Bible teaching. Your host, Eric Hovind, affirms the ultimate authority of God's Word, the truth of creation, and why it matters to you.
You've probably heard the much stated fact in modern science that humans and chimps share 98% of their DNA. Well, this scientific fact isn't just wrong, it's wildly misleading. So what if the story we've been told about human evolution isn't based on objective science at all, but is actually just based on carefully selected data and an evolutionary assumption? Guys, today we're going to cut through the noise of all of this with a man who knows the genome inside and out. He's got a Ph.D. in genetics, Ph.D. in genetics, not a Ph.G., a Ph.D. in genetics and years of hands-on research. He's challenging one of evolution's favorite talking points, the so-called genetic closeness between humans and chimpanzees. And today, honestly, I need you to just forget the headlines, forget the hype. We're going to dive into what the actual data reveals. And once you understand the data, it's going to help you view yourself and view others from God's perspective. So buckle up, guys. This is not just another biology lesson. This is a reality check. This is where secular science will bow the knee to the Creator, as the data will show. Hey, if this is your first time joining us on the Creation Today show, welcome. I'm your host, Eric Hovind. Our mission is pretty simple. We want to disciple the entire world, one person at a time. And today, I'm so glad that person is you. To everybody tuning in through social media, welcome. If you're enjoying the conversation, please hit that like button for us. And if you like the content and you think it's worthy, we'd love a follow and a subscribe as well. Let's dig deeper into the world of creation today, guys. To my television audience, by the way, I'd love to hear where you're tuning in from. If you have time to send me an email, let me know where you're listening to. I would love it. You can message me at erichovind@creationtoday.org. Now, I told you we've got a PhD in genetics in the house with us today, and you need to know something. He's not just a scientist. He's a code breaker in the ongoing war for truth. He's got years of research deep into the heart of the human genome. He's dismantled one of the most sacred pillars of evolutionary theory, the idea that humans and chimps are nearly identical. And while others accepted the headlines, he examined the data. Where others saw similarity, he saw purposeful and intentional differences in the design. He's written the reports, he's published the research, and he's stood against the evolutionary tide with conviction and with clarity. His work doesn't just expose the cracks in the 98% myth, it pulls back the curtain and points to something far, far greater. We are not cosmic accidents. We're not the product of goo to you by way of the zoo, guesswork, blind chance. We are intentionally crafted image bearers of a living Creator. My guest is here with us today, not just to present science, but to reclaim the story of who we are with a message that restores purpose, hope, and eternal significance. Ladies and gentlemen, please help me welcome my friend, Dr. Jeffrey Tomkins. Dr. Tomkins, welcome to the Creation Today show, sir.
It's great to be back.
Oh, what a privilege to get to talk to you. I just saw you recently at the CRS conference, and now hearing your report there and seeing where we're at with the human genome, I'm just kind of blown away that this, let me just put it this way, this is a good time to be a creation scientist. What are your thoughts on that?
Yeah, absolutely. In fact, we'll get to it later, but some research has just come out earlier this year that has actually vindicated about 10 years of research that I've been working on. It was a report out of the Genome Center up in Seattle at the University of Washington. So we can get into that a little bit later. I can't wait. We will touch on that.
I am blown away by how this mantra has been just ingrained in people over and over and over. So much so that I've been watching videos recently of people that are trying to claim that, oh, you have tried to deceive people. You don't even know what you're talking about. Your genetics is so poor because you're presenting a very different idea to we share 98, 99% genetics with a chimpanzee. And they're just trying to really trying to create ridicule to dismiss. But you've got the facts, you've got the receipts to back up what you're saying. So, like, what happened here? And you've been doing this for 10 years. What happened here? Can you back up and give us the story of kind of how this has played out?
Yeah, absolutely. So I was working at Clemson University running a genome center, and I decided to take the leap and move to ICR, the Institute for Creation Research here in Dallas, and that was in 2009. And so I get to ICR, and the president of ICR at that time had a talk with me and another biologist that was at ICR. He has since left. Actually, he left shortly after I came here, within about a year. And but anyways, so the president says, we hear in churches all the time, people are saying, what's the deal with this 98 to 99% DNA similarity between humans and chimps? And so he asked me and this other scientist, can you guys do something about this? And he said, I want to answer in 6 months.
Whoa!
I had just got here, and I'm like, I didn't know what to say about that. But the other scientist said, that's not going to happen in 6 months. And he was absolutely right. So it's been quite the journey. So the first thing I did investigating that issue was, first thing I did to investigate this issue was, like any good scientist would do, you go to the literature and you see, what's been published and how did they do it and how did they come about, their data that they're presenting. So there were 6 papers that were, I would say, the top papers that claimed a 98.5 DNA percent similarity between humans and chimps. And as I read through these papers, the first thing that really popped out was that they were only really comparing DNA sequences between humans and chimps that were already highly similar, like protein coding genes and other regions that were very similar. And I also noticed they were throwing out a lot of data that was not similar, that didn't give them those high percentages. And there were actually probably about 4 papers where I could actually factor data back in that they had thrown out. And I was coming up with anywhere between a 66 and an 86% DNA similarity between humans and chimps when I factored the data back in. And so obviously there was a bunch of monkey business going on.
Well said.
I would say it like that with these papers. And of course, it's just cherry picking is what it is.
So they literally compared what DNA is similar to in humans and chimps and compared the similar DNA, and that's where they came up with the similarity of 98 to 99% because all they did is compared similarity to similarity.
Yeah, and I actually sent an email to one of the researchers of one of the papers, and he basically just said that because I asked him, why did you compare this particular region between humans and chimps? And he basically said, because we knew they were similar. That this region was high. Yeah,
it.
So after that, I'm like, well, I just need to start downloading my own DNA sequence data and see really what's going on here. And so I downloaded just a lot of chimp DNA sequences, and I began comparing those to human. And I published an original paper, and I think I was coming up with like a 70% DNA similarity in that paper. But one thing I didn't realize is that the algorithm was kicking out DNA sequences. And actually an evolutionist read my paper and actually noticed that and said, hey, I think your algorithm's kicking out DNA sequences, because I think he tried to repeat some of the work I did. And so I checked it out, and sure enough, the algorithm was kicking out DNA sequences. So I actually had to contact the NIH, who developed the algorithm, National Institutes of Health. And so I was going back and forth with some of the software developers. I was sending them my data and outputs and everything, and they were actually able to fix the algorithm based on my back and forth with them. And the problem was is that no one had ever used this algorithm before to literally, we call it blasting or query, millions of DNA sequences. Typically people use this algorithm just just with a few DNA sequences. They don't do a high throughput type experiment like what I was doing. So they modified the algorithm and fixed it so I could reliably use it, for massive data sets with millions of DNA sequences in them.
And what time frame is this? This is around you started 2009, so this is 2010, 11, 12, somewhere in there?
Yeah, so I started the project, I think about 2010. The paper I published was in 2011. And
that's the one that the evolutionists corrected and said, hey, I think, and it wasn't your problem, it was, hey, this algorithm is actually kicking out some information that it should not be kicking out.
Right, because I was using such massive data sets, the algorithm was never really designed for that. So anyways, they fixed the algorithm, and so I did another project where I actually showed different versions of the algorithm and how it was actually behaving itself. And so anyways, I think that paper was published about 2015. And so with that paper, I came up with about 85% overall DNA similarity between humans and chimps. And another thing that I also did in another paper was I wanted to really know, what's going on with this data, because I was beginning to see a lot of reports of human DNA contamination in public databases. In fact, several papers came out showing that the human DNA was ending up in bacterial genomes, in all kinds of non-primate genomes. No one ever actually checked to see what was going on with primates and humans, but actually 3 million bases of zebrafish chromosome number 3 was entirely human. And so how does this human DNA get into these data sets? Well, it's floating around in the air through the heating and air systems. It's on your fingers. Even when exhaling, you can exhale DNA out into the air, or sneezing, or even just sitting there at the bench, working and talking with your lab buddies. DNA can just get into the reactions. And so anyways.
So literally there's human contamination everywhere, and they just didn't realize. They're looking at this going, did they look at it and realize it was contamination, or were they thinking an evolutionary perspective?
No, they were just saying, what's going on with this human DNA popping up in bacterial genomes and fish genomes. And so I'm kind of wondering, well, how much of the chimp genome has actual human DNA in it? And of course, that would be difficult to surmise in a lot of ways, because humans and chimps are probably the most similar creatures on the face of the earth. So how would you do that? So I set up relational databases. That's the nice thing about this old type of DNA sequencing called Sanger style sequencing. That's the chemistry, is that there's a lot of metadata with just the DNA sequence. And so you also have like the location where the DNA sequence was produced, the date it was produced, and other things. And so the one thing that I found out by doing that was that the DNA that was produced in the first half of the chimpanzee genome project using the Sanger style sequence was 6% more similar to human than the DNA sequence that was produced in the second half of the chimp genome project. 6%. And so obviously, they were cleaning up their act, so to speak, as time went on to avoid, contamination. So
the percent similarity, some of that had to do with contamination.
And not only that, but the the early versions of the chimpanzee genome were assembled based on the human genome. So in other words, how do you sort out these millions of chimp DNA sequences? Well, it's kind of like putting together a jigsaw puzzle. You put together a jigsaw puzzle by looking at the picture on the box, or maybe there's a little, poster in there that shows you what it's supposed to look like. And so basically they hung all these chimp DNA sequences onto the human genome to put it together. Well, it's very interesting. That basically humanizes the chimp genome. Yeah, on top of the fact you've got maybe 5 to 6% or even more human DNA in the mix in there as well. So these early versions of the chimpanzee genome had major problems, and so this whole project was just like opening up a complete can of worms, so to speak.
Wow, and you're having to discover this. You're having to realize, oh wait, we got contamination going on. They assumed evolution in order to prove evolution. They kind of, what's that logical fallacy? They literally said, hey, let's compare the chimp. Let's hang it on the human skeleton and see where it fits. That's a whole other issue. So multiple issues going on here.
Yeah, and of course that technique is quite common in genomics. You're sequencing a new genome and you want to sort it out, so you pick its closest evolutionary ancestor that has a more complete genome, and then you put things together in that way. It's called using one as a scaffold. So the human genome was used as a scaffold to sort out all of the chimp DNA sequences that were produced. So the Sanger-style sequencing typically produces DNA sequences about 700 to say 1,200 bases or DNA letters long. And so progress was being made in the chimpanzee DNA sequencing community. They actually sequenced the Y chromosome of chimpanzee using the same techniques that they used to sequence the human genome by developing very accurate genetic and what we call physical maps. I don't want to get into the technology on that, or we'd be here all afternoon. But
okay.
And so they actually sequenced the chimpanzee Y chromosome based on its own merits, and they found out that it was just radically different. In fact, they compared the differences between humans and chickens as far as how radical the DNA sequence was on the Y chromosome. So that was
that's only been able to sequence 600 to 700 base pairs at a time. And how many base pairs would be in a chimp or a human? How many are we talking? So you're getting a little bit of snippet, 600 to 700 out of how many?
So a single genome equivalent in human, let's say the set you got from your mother would be 3 billion bases long, roughly.
Whoa!
And then you also have a genome that you inherited from your father, which is another 3 billion. So you actually have 2 genomes in every cell in your body, one from your mother, one from your father. And the chimpanzee genome is about 3 billion bases as well. Actually, it's a little bit bigger than that. It's a little bit larger than human.
So we're putting the jigsaw together, and our pieces are 600 to 700, and the actual jigsaw puzzle is 3 billion.
Yeah, so kind of getting back to my story here. So that paper on the Y chromosome came out in 2010, and that was done at Washington University in St. Louis, I believe. And they actually created a chimpanzee framework for the Y chromosome to put the sequence onto. So that was actually the first, unbiased chimpanzee DNA sequencing project that there was. And then later on, they invented a new, what we call long read DNA sequencing technology, where you can create, instead of like 700 to 1,000 base snippets of DNA, you can create 30,000 to even up to 50,000 bases at a time. And so when you're creating those long reads, you can pretty much tell right off the bat if you've got any contamination in it. And so with this new DNA sequencing technology, they actually sequenced the 8 genomes, and this was done up in Seattle at the University of Washington. And So they published a paper in 2018 where they actually sequenced a chimpanzee, orangutan, and gorilla using this new technology. And they said in the paper that previous versions of ape genomes had been humanized because they used the human genome as a scaffold to hang the sequences on. And so they did that with orangutan and gorilla too. So in this paper, they claim, oh, we have created de novo genomes that are based on their own merits. We didn't use human as a scaffold to sort everything out because all of the DNA sequences were so long, we could just, find the overlaps between everything and put it all together that way. So that paper was published in 2018. And so I think it was very interesting that they admitted previous versions of ape genomes had been humanized. So now coming to 2024, or I guess this other paper was published 2025, but the majority of the work was probably done in 2024. They took a second and more comprehensive effort at sequencing the ape genomes. And so that paper was quite groundbreaking. In that the 2018 paper, I don't remember them saying anything about what the similarity was necessarily. They're kind of skirting around the issue. But in this other paper that was published earlier this year, they literally said in the paper, it wasn't in the paper itself, which was about 17 pages long. It was in the 171-page supplemental material. It was buried literally in the middle of that, where they said that the human and chimpanzee genomes, based on just comparing single genomes, what we call a haploid equivalent, were 85% identical, 85% DNA identity between the two. But when they compared the diploid genomes against each other, it was 84% DNA identity between them. So why is that important? Because in 2018, I published a paper where I actually used the DNA sequences they produced from that 2018 paper. So I downloaded those long DNA snippets, and on average, they were 30,000 bases long, which is pretty long. And so I queried those or blasted those against the human genome. And, I used pretty liberal parameters with the algorithm to allow for gaps. And only about 10,000 bases of those 30,000 bases per DNA sequence I could align onto human before the DNA became so dissimilar the algorithm just gave up and stopped because it was outside of its parameters. So in other words, it hit a gap so big it just couldn't get through it. So those alignments that I did get that were about on average 10,000 bases long each, I came up with 84% DNA identity, average DNA identity between humans and chimps. The exact same number that they came up with earlier this year in a paper that was published, I believe, in Nature. And so anyways, so I was completely vindicated there.
Yeah, I'm like, who's following who here? It sounds like they're following your work. Maybe that's what's really going on. They're just not talking to you about it.
No, I think, anyways, so I felt really good about that.
Yeah.
Because I was kind of at the point where, well, there's nothing more I can do, at this point. I don't have the big lab and the resources like these big genome labs do. I said to myself, I'm just going to wait. Let's just wait, see what happens. Eventually, the truth will come out. And sure enough, it did. And so, what's really interesting is that 84% is only the regions that they could line up. I think they said there was about 6% of the chimp DNA they could not align to human. And what about if you did the reverse, human onto chimp? How much of the human DNA could you not align to chimp? So in other words, these studies really don't tell you, what is missing in chimp compared to human and what is missing in human compared to chimp. So, you know, so the DNA similarity is actually, less than 84% if you consider those regions of the genome, missing in one and absent in the other, and vice versa. So,
Wow. Now, how much, I got to let social media go here in just a minute, but how much, so if we called it just the 15% and didn't even go 16 or the 20 plus, if we had those other regions and said, hey, apes and humans realistically, based on the data, are really about 15% different, 85% similar. How important is that 85%? Why is it? And then how important is that 15%? Like how is that detrimental to the evolution worldview that, oh yeah, you just changed a few things and we came over to human beings?
Like I said, I think the similarity is much less when you factor in what I just mentioned previously. But so, what if the genomes are only, say, 15 to 20% different? What does that mean in light of evolution? Well, human evolution is a highly theoretical concept. And so they look at mutation rates in humans, they look at mutation rates in chimps, which are actually, pretty similar. And they have a model, it's called the neutral theory of evolution, where supposedly there's large regions of our genome, or the human genome or the chimp genome, that are just randomly evolving. It's just junk DNA, it's not doing anything. And so they have a lot of things they factor into these statistical paradigms, if you will. They factor in deep time. And so according to it depends on the paper you read. There are claims that humans and chimps diverged from a common ancestor anywhere between 3 and 15 million years ago. And so I think that generally the more common number is around 6 million is what they claim.
That's what I've heard. That's what I've said, yeah.
Yeah, but I did see a paper where they claimed 15 million. So, yeah, so anyways, based on these models, you actually need close to a 99% DNA similarity for these statistical models to work. And anything outside of that pretty much, ruins the whole paradigm.
Whoa.
And so a 15 to 20% difference would totally muck up, all of these statistical models that they've done to try and link us back at some point in the ancient past to a common ancestor.
So if 1% is to 6 million, 6 times 15, 90. So you would need at least 90 million years to do the 15%, and the evolution paradigm has no way to account for 90 million years to go from chimp-like creature, ape-like creature, to human being.
Yeah, it just doesn't work.
Whoa! This is a death blow. When you get into the data, it really is a death blow to the evolution worldview. And guys, if evolution isn't true, there's only one other game in town. I know people will go to spirituality or go to other things, but there really is only one other game in town. And listen, I know you're here because you want to be confident. Confident that science doesn't contradict the Bible, but confirms it. And yet, we are living in a culture that is constantly preaching a different gospel. Their gospel is that humans are just advanced animals, barely different than chimps. Accidents of time, chance, and mutation. And that kind of messaging doesn't just confuse, it undermines identity, purpose, and the gospel itself. No wonder we're having so much crisis today, so much anxiety today of who we are. But hey guys, I got good news. What Dr. Tomkins has done and organizations like the Institute for Creation Research and Creation Today is we're cutting through the noise. I mean, with decades of genetic research, Dr. Tomkins is helping reveal what the evolutionary establishment won't tell you. Humans and chimps are not 98% identical. And the data shows it, guys. The human genome doesn't point to randomness. It points to design. And now it's your turn to take action. I want you guys to get equipped. That's step number one. You need to subscribe to the newsletters at icr.org and at creationtoday.org. Just go to icr.org, get their Acts and Facts. It's a free publication. They'll send it to you is it every other month, Dr. Tomkins?
Yeah, it's every 2 months.
Yeah, every 2 months, you're going to get the scientist writing you personally and saying, hey, here's what we've discovered. Here's what we found out. Here's some information. It's going to keep you equipped. So, and there's free articles and videos on ICR.org that will help strengthen your faith and sharpen your understanding of God and His Word. And number two, I need you to share it. Don't just keep this to yourself, man. Talk to your friends, talk to your coworkers, talk to your family. Did you know the whole 98, 99% similarity between humans and chimps has been completely debunked? So you could share this episode, you could share the work that Dr. Tomkins has done, or the social media work that ICR has done. Send somebody a text. Guys, post it, because silence never changes the culture. Truth does. And then number three, I would love for you to stand with us, okay? Support the mission of Creation Today. Support the mission of ICR. Be part of the movement that's reclaiming science for the glory of God and raising up a generation that's not afraid to stand on the authority of Scripture. So if I were you, I would take those steps and I would take them today. Sign up, share, and support. Guys, I'm telling you, it's so important. If we don't speak up, the false narrative that humans are just animals is going to continue to shape hearts and minds, especially the next generation. And we're not going to let that happen on our watch. So let's stand together boldly, faithfully, and unashamedly on the truth of God's Word as we push back against the lie that we're nothing more than glorified apes. You were created in God's image, and now you are armed with some of the science that backs it up. Hey, if you'd like to join me for the rest of this conversation, come on over to creationtoday.org. Partner with us to help spread the gospel around the world. And anybody who helps us spread the gospel, they get access to everything we do or have done. And I think you'll really enjoy the next half of this conversation, plus all the other conversations that we've ever had. So come on over to creationtoday.org and partner with us. Hey, between now and next week, got a great show for you next week. Between now and then, go do these 3 steps. Share it. Support it. Sign up to get the updates. Let's do these 3 steps and let's be involved in this work that's so important for the glory of God. All right, we look forward to seeing you next week. Until then, go share your faith with somebody who needs to hear it.